So let's continue with example 5 from last day and do a second part. So far we left off by coming up with the equation of the median line, and we came up with y equals x plus 2. And that was the equation of this median line. So just recall that we found the midpoint first, and we used the y equals mx plus b, and we determined the slope by using these 2 points, and we plugged in a value of b for x and y, and we found the y-intercept. So let's continue and find the midpoint of the other 2 sides and draw those medians. So the midpoint of BN, so we're going to find the middle of B and N. So it's going to be somewhere in here, and we don't know exactly where it is at this point. So let's use our midpoint formula. So we have our x1 plus x2. So we have 4 plus our negative 2, and our 6 plus our negative 4, and we divide both by 2, and we come up with a coordinate point of 1, 1. So that we'll label as point S, because we already used M, so we'll just use another letter. And so that point is at 1, 1. So 1 and 1. So we'll draw our midpoint in here, and then we'll draw our median, which goes across to the vertex of the opposite side. Let's look at the midpoint of AB, our final side. So we're going to look at this side and find the midpoint, which will be along here somewhere. So we'll use the same formula, and we'll add our negative 6 plus 4 and our 0 plus 6 and divide both by 2. And notice that it doesn't matter in which direction that we add. It is good to go in the same direction for both x and y, however. And we get a value, or we get to a coordinate point of negative 1 and 3. So let's find out where that is. We'll call that point T, and you can use any letters that you wish other than ones that you've already used. So negative 1 and 3. So negative 1 and 1, 2, 3 is right here. We'll draw our midpoint, and then we'll draw our median, which goes to the vertex on the opposite end. So now we have our 3 medians, and notice that there is a point here where they all seem to intersect right in the middle here. We're going to put a point there. And that's a special point. And that is called a centroid. So we have a new definition, a centroid. A centroid is the intersection point of all the medians. And it is also known as the center of gravity. Now what that means is, if we were to cut out this triangle out of our piece of paper and hold it up in the air flat, and if we were to put our pencil point right here, the whole triangle would balance on that point. It would not fall down. So it's called the center of gravity because it's equally weighted, and the triangle can balance on that point. So that's a very unique and special point. And a question I'd like to ask you is, how would you determine the coordinates of that centroid? So if we had to find out what the coordinate points of that centroid were, how would you be able to find that? So I want an x and a y value for where that is. Notice it's kind of in the middle of a square, so it might have a decimal answer for the x and y, but we certainly can't guess where that is exactly. So have a think about how would you determine where that is, and we'll discuss that afterwards and see if anyone has any good ideas. Let's look at example 6, the circle. We're asked to find the midpoint of the circle. So we're asked to find the coordinate points of this midpoint here. We do have a diameter here which cuts across the center and touches 2 points on the edge of the circle. One point is A, that's at 0, 7, and this is point B at 12, 3. So we could use those 2 endpoints of our diameter to find the midpoint of AB. And notice the notation that I use. We call it M for midpoint, but also we use a small letter AB to denote which line we're talking about, because you might be finding a lot of midpoints of several different lines. So we want to say or let people know what line we're talking about. So it's line AB, midpoint of line AB. So we're going to add our x's, which are 0 and 12, and we're going to add our y's, 7 plus 3. Dividing both by 2, we get a point of 6, 5. So let's label that point, our midpoint, 6, 5. Now we're going to determine the area of a circle. And recall that the area of a circle is pi r squared. So we know pi, we just don't know r. We need a radius. And a radius would be the length from here to here or from here to here. And we do have a formula for length that we learned the other day. So let's use AM and find the length of this, and that'll give us our radius. So recall that our length formula is 7 minus 5, our y's subtracted and squared, and then our x is subtracted and squared, so 0 minus 6 squared, and we'll square root each of those, so this would be 2 squared and negative 6 squared, and that would give us 4 plus 36, and so it's square root 40. We'll leave our answer like that because square root 40 does not have does not give us an even number if we take the square root. Let's plug that length into our area formula. So area is pi r squared for a circle. So we have pi. We just found out that our radius is square root 40. We have to square that. So the square and the square root cancel, so really it's just pi times 40, and that's 125.7. So that's the area of our circle. Now I've just added an additional question to this, so if you could add this as well. I'd like to come up with the equation of the perpendicular bisector to AB. So here's another definition that you need to know. What is a perpendicular bisector? Well, let's draw it on here. So the two words mean something each separately. Perpendicular means at a right angle. So notice that the blue line is at a right angle to the red line. And also bisector, like bicycle, means two, cuts a line in two equal parts. So notice that this blue line also cuts the red line into two equal halves. So that's called a perpendicular bisector. Now we want to come up with the equation of that line. And we know that we use y equals mx plus b, and we always start off with finding the m and then finding the b. So if we wanted to come up with a slope for this, we don't have any points on that other than the midpoint. We need 2 points for a slope. So why don't we start with the opposite line? Let's find out what the slope of AB is. If we could find that, we know that this slope would be the opposite, or the negative reciprocal of it, if you remember what that is. So the slope of AB would be our y2 minus y1 over x2 minus x1. So what we've done is our 7 minus 3 divided by our 0 minus 12, and that gives us negative 4 over 12. And we could also reduce that to negative 1/3. Now that's the slope of the red line. And that helps us because if we could come up with the negative reciprocal slope, that will give us the slope of the blue line, which is essentially what we want. So what would the opposite of this be? So we have to flip it and change the sign. So 1 over 3 would be 3 over 1. And 3 over 1 is just 3, and we would make it positive. So we want to use 3 as our slope for our blue line. So now that we have our slope, all we have to solve for is b, and we know that we need to plug in a point for x and y. Now what is a point on the blue line that we know? There's only one. This point is shared by both lines, so we can use this point here for our x and our y. So let's go ahead and plug that in using our 0.65. So 6 for our x and 5 for our y. So let's just multiply this out, and bring that over to the other side to find out what b is. So 3 times 6 is 18. It will be negative over here. Negative 18 and positive 5 will give us negative 13. So we found our b. And then finally, we just have to plug it back in to this equation here. So y equals 3x minus 13. And that's the equation of the blue perpendicular bisector. So I've put a blue box around that to show which line it's for. Another example that I'd like to add to this note about midpoints is a thinking question. Now, if we're given a line, this question says that we're given half of a line, and we want to find where it ends and what the other endpoint would be. So M is actually the middle of this line, and this is the left half of our line. If we were to continue this and make it the same length, it would come down here, and I want us to find what the other point would be somewhere down here. Now, how might we go about doing that? So let's just notice that this is line segment EF, and it has an endpoint at E and a middle point at M. Determine the coordinates of endpoint F. So we'll call our other end of our line point F. Let's just notice that our rise is 6. So let's just check how we did that. So if we had to go from point M to E, how far up would we have to go? We'd have to go 1, 2, 3, 4, 5, 6. So notice, how did we get that? The rise is the difference in the y's. So notice what I did. 7 minus 1 is 6. That's the difference in the height. Okay, so that's our rise, it's 6. Now what's our run? Our run is our difference in our x's. So let's look at how we determine that. Our difference in our x's, how far over is this point M to E? So if we went up 6, 1, 2, 3, 4, 5, 6, we'd have to go left by 1, 2, 3, 4, 5. So our run is actually 5. Now how would we calculate that just given the points? We would subtract our x's. So negative 7 minus negative 2. That would be negative 7 plus 2, which would give us negative 5. So this means to go from point M to E, to go from point M up and over to E, we would have to go up 6 and left 5. Now if I want to find the other point down here, I would have to go in the opposite direction. So instead of up 6, I'm going to go down 6, and instead of going left, I'm going to go right 5. So let's draw in our line. Okay, so now we're going to apply the opposite to M. So for our y's and our x's, if we started at 1 for our y, we're going to, instead of add 6, because we went up, we're going to subtract 6 to go down. So 1 minus 6 will give us our new coordinate point. And instead of going left 5 for our x's, we're going to go right 5. So we're going to add 5. So it's going to be negative 2 plus 5. And so we end up with negative 5 and 3. So our point F is at 3, comma negative 5. This was our y and this was our x. So let's just check. Instead of going up 6, we went down 6. 1, 2, 3, 4, 5, 6. And instead of going left 5, we're going to go right 5. So that's 1, 2, 3, 4, 5. So there is our other half of our line, and there is our other endpoint.